All right, this video is for learning target 7, where we are dividing polynomials using synthetic division. Quick reminder of learning target 6, where we divided by long division. We were taking polynomials and dividing them by binomials usually, and we used a method from elementary school. There's what the work kind of looked like, but ultimately the answers are, highlighted for you there. We did a couple of those, and then the third one we divided by 2x plus 1, and it was much the same. Well, we're going to use the same problems for synthetic division. Uh, the problem is, though, when we get to example 3, I'm still going to say that the best way to divide by 2x plus 1 is to use this long division method. It's just kind of confusing when we use the new synthetic method. All right, so let's get to it. Hopefully, and you really need to stop the video if you haven't, hopefully you've read the Green Book, page 342, bottom 2 paragraphs, and all of page 343, because it walks you through this process and talks about x minus a or x minus r, depending on the book you're reading. In the Lizard book, they compare what you're dividing by to x minus a. In the Green Book, they compare what you're dividing by to x minus r. For consistency's sake, I'll stick with what you probably have read, the Green Book. So in example 1, when I'm looking at example 1, first thing I do is compare what I'm dividing by to x minus r. So the x's match up, the negatives match up, therefore r is 1. And again, if you haven't read the page 342 and you're not even sure what this looks like, you really need to stop the video and watch and look at those 2 pages. All right, so you'll need 3 lines in your notebook paper. In the first line, you have a half box and then the coefficients of what you're dividing into out to the side. Skip a line so that you can have a place to put your addition bar, and then leave a spot over here for your remainder. Okay, as you read on page 342, your R value 1 goes in this half box, and the coefficients of what you're dividing into, so in this that would be 1x cubed plus 3x squared minus 1x plus 2, that would be the coefficients 1, 3, negative 1, 2. So now the problem's set up, and again, you have 1 line for this, 1 line for the addition, and 1 line for your answer on notebook paper. You start the process as described on page 342 by bringing down this first coefficient, 1. Then you take your R value, whatever's up here in the half box, and multiply it by the answer you just got. So 1 times 1, 1 times 1. Put that answer below your next coefficient, and then it's an addition bar. So add those coefficients, 3 plus 1, 4. Continue that process until you run out of numbers. Take your answer 4 and multiply it by your R value 1, 4, and add your coefficients, negative 1 plus 4, you'll get 3. One last time, take your answer 3 and multiply it times the R value 1, so 3 times 1, 3, put it under your next coefficient and add. And synthetic division is done. Your answer is there, you just have to interpret the answer. The first number that you got on the right side is the remainder. So I kind of work backwards from there. The next answer, the 3, represents x to the 0, represents the constant of your answer. The next answer to the left of that represents x to the 1. And the next answer represents x to the 2. So put it all together, you have 1x squared. You have 1x squared, sorry about that. You have 4 x's to the 1s, and you have 3x to the 0, so you have 3 as a constant without an x, and you have a remainder 5. So that's one way you could write the answer, as we talked about in learning target 6. Or you could write the answer as x squared plus 4x plus 3. With that remainder 5, you could write it as a fraction, plus 5 over x minus 1. And just for the sake of looking, we'll look back at learning target 6 answers real quick. And you can see that those are the same 2 answers same answer that we got when we divided using long division. So these are long division and synthetic, just 2 different ways to perform division. All right, let's look at another example. Example 2. For starters, the thing that you're dividing into, again, like in learning target 4, is missing some of the place values. It's missing an x cubed term. So you have to insert 0x cubed to kind of hold that place value, just like before. It's also missing an x value, so we'll have to add a 0x in there. And then it has the 16. So when we set up our synthetic division, our half box, the coefficients next to it will be 1, 0, -8, 0, 16. And then we'll leave a line here to put numbers in, and then draw your addition bar there and put a remainder box to the side. All right, let's talk just a second about the x plus 2. When you compare x plus 2, the thing you're dividing by, to x minus r, the only way that says plus in the middle is if x minus r, if that r was a negative number. So in this situation, r is -2. So we'll put that in the half box, -2. And according to page 342 in your green book, the first step of synthetic, to get this thing started, bring the 1 down. And then start multiplying whatever's down in your answer, whatever number you got when you added, multiply that 1 times your r value, -2, and put it in the next column and add. Add your 0 and your -2. So again, next step, take your -2 that you got when you added and multiply it by the r value, -2, 4. Add your -8 and your 4, and you get -4. Take -4, multiply it times -2, the r value, you'll get 8, and you add your 0 and your 8, 8. Last time, you take your answer 8 and multiply it times the r value, -2, you get -16, and when you add them this time, you get 0, which makes sense. That's where the remainder goes. And as is noted above, x plus 2 is a factor. So when you divide a factor into the thing you're dividing into, the dividend, you should get a remainder of 0. All right, so working backwards to the left, if the remainder is 0, 8 is your constant. 8 is the x to the 0 term. -4 is your x to the 1 term. -2 is your... Sorry about that again. Working backwards here, that was the -4 was the x to the 1 term. X to the -2, I'm sorry, the -2 is x squared term. And the positive 1 here is x cubed. And that makes sense that if you're taking an x to the 4th and you're dividing it by an x plus 2, you're going to take an x to the 4th, divide it by an x to the 1, it's going to give you an x cubed answer. So anyways, that was just a little side note there. But our final answer is 1x cubed minus 2x squared minus 4x plus 8. No remainder. So x cubed minus 2x squared minus 4x plus 8. That's what you get when you divide x to the 4th minus 8x squared plus 16 when you divide that by x plus 2. Right, if I were at home watching the video and feel like I have a good handling of long division and synthetic, I'd probably stop right there and remember that anytime you're dividing by 2x plus 1, anytime you're dividing by something that has a number in front of x, just use long division. What's going to happen is we're going to have some fractions in our answer if we do synthetic division, and then we're going to have to adjust our remainder. So for those that want to continue watching, I'm going to work it just so you know how it works with synthetic. But if you're not interested in doing this problem with synthetic, just always do long division in that situation. But for the sake of those still listening, if you compare this to x minus r, 2x plus 1 compared to x minus r, you're going to have to divide by 2 for that to say x minus some number. And when you divide this by 2, you get x plus a half. And now you can compare that to x minus r, and your r is -1/2. All right, the thing is, the thing about it though, when you divide what you're dividing by 2, you've just changed the problem. So you got to remember to come over here and divide what you're dividing into by 2 as well. So essentially, performing this division, 2x squared plus 4x plus 5 over 2 divided by x plus a half. So that's really what you're dividing to use synthetic division. So you set up your half bar, your remainder, don't need quite that big of a bar, but we'll make it work. Your R value is negative 1/2. Your coefficients are 2, 4, and again, making that work, some big numbers. 2, 4, and 5 over 2. And then you proceed like normal. Bring the 2 down. Negative 1/2 times 2 is negative 2. Add the 4 plus the negative 2. Wait a minute. Negative 1/2 times 2 is not negative 2. It's negative 1. Sorry about that. Add the 4 and the negative 1 and you get 3. Multiply your answer 3 times negative 1/2, the R value, and you get negative 3 over 2. When you add them, you get 1. Now, this is where it gets kind of weird. This is, again, why I don't recommend using synthetic division here. Your answer is 2x plus 3 plus a remainder of 1, but what you divided by was x plus a half. So what you have to then do is take the remainder part over here to the side, and you have to adjust and turn it back into what you really divided by, which was 2x plus 1. And the way you do that is multiply this by 2 over 2. Thus, the denominator x plus a half times 2 becomes 2x plus 1, and the numerator becomes 1 times 2 becomes 2. So thus your final answer is 2x plus 3 and a remainder of 2 over 2x plus 1. So as you can see, that's kind of, well, there's a lot to remember and a lot to do when you're using synthetic this way, when there's a lot less to do when you use long division to divide by 2x plus 1. So for what it's worth, that's my recommendation. If you're dividing by anything that has a number in front of x other than 1, then you need to use long division. All right, so that will do it for the synthetic division note.